And action. David, go!
Action,
I said action, dude.
Whoa, dude. So there's a panda right over there, look. Oh, my derivative. Wow, that's probably the biggest one I've ever seen. Such a majestic creature. Oh my god. Those are rare. I can't believe we found one. Wait, beautiful thing. What is the thing to the right of the booth? What is that a person? Is he blind? Oh my god, he's walking to the panda. Oh my god, he's going into anaphylactic shock. He's gonna die. Look, over there, 3 wild EpiPens.
EpiPen!
EpiPen!
EpiPen.
He needs help as fast as possible. Which EpiPen should we use? Let's use calculus.
So the situation at hand requires David to get an EpiPen and travel to the blind man. On this map, we have David and Zach in the top left corner. David's first option is to travel downward to grab EpiPen 1 and then go diagonally to the blind man's location. David knows that he can run 11.73 feet per second without an EpiPen and 7.33 feet per second with an EpiPen. To calculate the distance of this route, we have to use the Pythagorean theorem to find the hypotenuse of the triangle formed. When we do that, we get an answer of root 9,000 feet. So clearly then, we can use this answer in a simple distance formula to calculate how long it will take David to run this route. After plugging in the numbers, we get an answer of 15.5 seconds.
Option 2 is very comparable to option 1, except David is going to be traveling to the other corner. Now let's do the math. Using the hypotenuse found in our first calculations, we can use a quasi-identical process to find the time it will take David to run this route. Plugging our value of root 9,000 feet into a slightly altered distance formula gets us an answer of 12.18 seconds.
Nice! So option 3 requires more than just simple Algebra 1 concepts. Similar then to before, we need to again use the Pythagorean theorem to calculate the distance of this route. By utilizing what we know about the dimensions of the rectangle, we can label the bases of the triangles x and 90 minus x. Now that we have expressions for the distances, we can write the new distance formula to solve for how long it will take David to run this route. By taking the derivative of this equation, we can solve for x. Plugging this derivative into a graphing utility, we can reach our x value of 68.97. This value, when plugged into the original formula, gets us a time of 11.41 seconds.
So what does all this math mean for the blind man? Option 1 would have taken 15.5 seconds. In that time, the blind man would have died. Option 2 gave a slightly better time of 12.81 seconds. But he still would have died. The man would have survived with option 3.
Do your thing, EpiPen! EpiPen! You're welcome! Damn kids! Are you on?
Yeah, I'm good, dude. I'm ready to go. Oh! You forget how to fly! Oh, Jesus!
This has never been seen before. There's an alien craft right over there. Let's go take it down. The military.
What is your accent? It's landing! Eric, get away!
We're going! We're doing it! We're filming a video!
I'm so tired.
Here you see the natural EpiPen in its habitat, mating with.
The
Oh my God! I've never seen a mount that's violent.
Whoa! There's a panda right there! Dude, right over there! Look! Oh my derivative! Oh my derivative!
Come on! Come on! We gotta get this! We gotta
Say it so perfect. There's a panda right over there, look! Oh my derivative!
That's good, that's good.
That's good.